This is Quiz 3, Study Guide. Number 1 says to find the length of the missing side, leave your answer in simplest radical form. You can scratch that out. We're going to round everything on the quiz or on the study guide today and on the quiz tomorrow to the nearest tenth. Okay? But make sure you guys know how to convert radical to decimal. Okay? So you got a right triangle here. You got a leg that's 10. You got a leg that's 14. Okay? First thing you want to do is label the sides. The sides that make up the right angle are A and B. The hypotenuse is C. And the Pythagorean theorem says that 10 squared plus 14 squared equals C squared. So 100 plus 196 equals C squared. So 296 equals C squared. And the square root of 296. Alright, the radical form is 2 times the square root of 74. And then in your calculator, you have to find the square root of 74 and you have to multiply it by 2. And that's going to be 17.2. Number 2, another right triangle, but in this case you are finding the hypotenuse. You're given the hypotenuse. So the hypotenuse is 13, one of the legs is 10. You're looking for the other leg. So label the sides again. A, B, and C. (10 squared plus b squared equals 13 squared. Square everything. Subtract 100 from each side. (169 minus 100 is 69, and now you're going to find the square root of both sides. So b is going to be equal to 8.3. Three through 13 now, they're all in text. You're going to have to draw the pictures. So number 3 says that triangle ABC has side lengths 3, 4, 5. Do the side lengths form a Pythagorean triple? If your side lengths are 3, 4, and 5, remember a Pythagorean triple, a set of non-zero whole numbers such that the two smaller ones squared and added together equal the third one squared. So the question here is, does 3 squared plus 4 squared equal 5 squared? Does 9 plus 16 equal 25? Well, yes, it does. So yes, they are a Pythagorean triple. Number 4. A triangle has side lengths of 12, 35, and 37. Classify it as acute, obtuse, or right. In this case, you take the two smallest sides. You take 12 squared plus 35 squared, and you compare it to 37 squared. So 144 plus 35 squared is 1225, and you're going to be comparing that to 37 squared, which is 1369. So 144 plus 1225 equals 1369. So since these are equal to each other, since a squared plus b squared is equal to c squared, it's a right triangle. What I would do is go in your notes and write the other. Well, you've got your notes, right? Remember, if a squared plus b squared is less than c squared, what is that, an obtuse triangle? And if a squared plus b squared is greater than c squared, it's an acute triangle. All right. Number 5. A grid shows the position of a subway shop and your house. The subway shop is located at. All right, you're going to draw a coordinate plane. Your x is the horizontal axis, your y is the vertical axis. The subway shop is at -7, 8. So -7 and 8 would be here. -7, 8. Subway shop. Your house is located at 6, 4. 6 and 4. What is the distance to the nearest unit between your house and the subway shop? So we did this earlier in the year. You plot the 2 points and then you connect them. Now you're going to find the distance of this segment, and you're going to do that by dropping a vertical down to the 4, and then you're going to run a horizontal across to the 6. This forms a right triangle. This vertical leg goes from 4 to 8 on the y-axis. So it's 4 units. This horizontal leg, it goes from -7 to +6. So it is 13 units long. Now within that triangle you can label the sides. You've got A, B, and C. So your math is 4 squared plus 13 squared equals c squared. So 16 plus 169 equals c squared. So 185 equals c squared. If you find the square root of each of those, $13.6 is the decimal that you get, but it says what is the distance to the nearest unit? 13.6 becomes 14. To the nearest unit, that means the nearest whole unit. So 14 units from the subway shop to your house. Number 6. Number 6 is, it was on there by mistake. It's the same as 5, so just cross it out. And then you got number 7. You're told that a triangle has side lengths of 27, 79, and 84. Is it a right triangle? Well, you're going to take 27 squared plus 79 squared, and you're going to compare it to 84 squared. 27 squared, 729, plus 79 squared, 60, let's see, 79 squared, second, there. $62.41. And you're comparing that to the 84 squared. $70.56. So your 729 plus your 62.41 equals 69.70. So 6970 does not equal 70.56. So is this a right triangle? That's no. If you were choosing an explanation in a multiple choice, your answer would be that a squared plus b squared does not equal c squared. Therefore, it's not a right triangle. Number 8. The area of a square garden is 98 meters squared. How long is the diagonal? This would be your picture. Here's your square garden. You're told that the area, or let's do this, the area of a square equals a side squared. And you're told that the area equals 98. So if the area equals a side squared and the area equals 98, then a side squared equals 98. And if you find the square root of both sides, then one of the sides is equal to, 7 square root of 2, which is 9.9. So one of these is 9.9. Now, this is a square garden. So here's your 90. Here's your diagonal. Okay? Now, a square and a diagonal means that this is 45 degrees and this is 45 degrees because all the sides are congruent. So the angles opposite those sides are congruent. So this is a yesterday problem application. This is a 45, 45, 90 right triangle. It's a special right triangle. Remember we said the hypotenuse was a leg times the square root of 2? So this diagonal that you're trying to find is going to be equal to 9.9 times the square root of 2. So I got that number in my calculator. I'm going to push times. And we get 14. So the length of that diagonal is 14. Number 9. Quilt squares, keyword squares, are cut on the diagonal to form triangular quilt pieces. So there were squares that are cut on the diagonal. So it's a square and it's cut on the diagonal. So when it's a square cut on the diagonal, here's your situation again. You've got a 45, 45, 90 triangle right here. The hypotenuse of the resulting triangle is 10 inches long. This hypotenuse is 10. What is the side length of each piece? You're looking for this right here. Yesterday we said that in a 45, 45, 90 right triangle that the leg was equal to the hypotenuse divided by the square root of 2. Okay? So if you take 10 and you divide it by the square root of 2, it's going to give you the length of this leg. So you're going to get 5 square root of 2, and then you're going to turn it into a decimal, which is 7.1. So each of these legs of this triangle are 7.1. Number 10. The length of the hypotenuse of a 30, 60, 90 is 9. Find the perimeter. Find the perimeter. So here's your triangle. It's a 30, 60, 90. The hypotenuse is 9. Yesterday we said that in a 30, 60, 90 triangle, the short leg is equal to the hypotenuse divided by 2. So your short leg is 4.5. We said that the long leg was equal to the short leg times the square root of 3. So your long leg is 4.5 times the square root of 3. The question is to find the perimeter. Well, the perimeter of a triangle is equal to the sum of the sides. So if you take 9 plus 4.5 plus 4.5 radical 3, what you get is you can add these two together. They're called like terms. So you get 13.5 plus 4.5 radical 3. And then you can type this, or you can do this work in your calculator. So 13.5 plus 4.5 times 21.3 is the perimeter of that triangle. If you use a highlighter or anything like that when you're taking notes, on number 10 right now I would highlight find the perimeter, because answer A is probably going to be one of these side lengths. Answer B is probably going to be the other side length. But that's not what they're asking for, is it? You got to find both sides so that you can add all three of them together to get the perimeter. If you don't have a highlighter, circle the word perimeter on there. Do something to make that stand out so that you remember to add the three sides together. All right, number 11. A piece of art is in the shape of an equilateral triangle with sides 6. So we got an equilateral triangle. That means all the sides are the same. If all the sides in the triangle are the same, and one of them is 6, if all the sides are the same, all the angles are the same. If all the angles are the same and they have to add up to 180, then they're 60 degrees each. Find the area of the piece of art. Round your answer to the nearest tenth. So look, area of a triangle equals 0.5 times the base times the height. It says that all the sides are 6. So your base is right here. It's 6. What you need is this. You need the height of this triangle. When you put this altitude in here, or this height of this triangle, you bisect this top angle. You make the triangle on the left and right a 30, 60, 90. You also bisect this bottom side. So if the whole bottom is 6 and you just bisected it, this piece is 3. So look what you got here. You got a 30, 60, 90 triangle on the left. with a short leg of 3 and a hypotenuse of 6. And you need the long leg. So the long leg is equal to the short leg times the square root of 3. So now you have all the information to find the area. So the area of this triangle is going to be equal to 0.5 times the base of the entire triangle, which is 6, times the height of the triangle, which is 3 radical 3. So the area of this piece of artwork is 0.5 times 6 times 3 times the square root of 3, which is 15.6. Number 12. A sign is in the shape of a rhombus with a 60-degree angle and sides of 12. Find its area to the nearest length, to the nearest tenth. A rhombus, that's just a pushed over square, meaning all the sides are the same. All the sides in this case are 12. Forms a 60-degree angle here. And the area of a rhombus is equal to base times height. Well, it says all the sides are 12, so this top piece is 12 and this bottom is 12. This bottom can represent your base. The height of this rhombus would be this dimension right here. When you drop down this altitude, it forms a 90-degree angle, and this triangle becomes a 30, 60, 90. In a 30, 60, 90, we need this piece right here now. We need the long leg, okay? The long leg is equal to the short leg times the square root of 3. The short leg is equal to half the hypotenuse. So 12 divided by 2 is 6. There's your short leg of that right triangle. 6 radical 3 is the height or the long leg of that right triangle. Now you have all the dimensions you need to find the area of this rhombus. So the area equals the base, which is 12. It's the base of the entire shape. You got to use this 12 times the height of the rhombus, which is 6 radical 3. So the area equals 72 radical 3. And let's see, that is 72 times, that's 124.7. Area. And number 13. A conveyor belt carries supplies from the first floor to the second floor, which is 26 feet higher. The belt makes a 60-degree angle with the ground. Alright, so you got to draw this picture. You got this conveyor belt. It's going up like this. If we drop a vertical and we lay in a horizontal and we set this angle at 90 degrees, and it says that the belt makes a 60-degree angle with the ground. So this is 60 degrees. The second floor is 26 feet higher. 26 feet higher. What that means is that this hypotenuse is the conveyor belt. How far do the supplies travel from one end of the conveyor belt to the other? This would be one end of the conveyor belt to the other. This 26 is opposite the 60-degree angle. This angle, this third angle up here would be 30 degrees. You've got a 30, 60, 90 right triangle again. You know the long leg. If you find the short leg, you can double it. It'll give you the length of the conveyor belt. So we said yesterday that if you know the long leg and you need the short leg, you divide by the square root of 3. So this short leg is going to be equal to 26 divided by the square root of 3. So you can do that in your calculator. "15 units. Okay, so this is 15 units right here, or 15 feet. It's opposite the 30, so it's the short side of the triangle, short leg of the triangle. If you double it, it's the hypotenuse. So the first part of that question, how far do the supplies travel from one end of the conveyor belt to the other? They travel 30 feet. Second part of the question, if the belt moves at 70 feet per minute, how long to the nearest tenth of a minute does it take the supplies to move to the second floor? So this is a proportion problem. If you write a proportion of feet to minutes, all right, feet to minutes is equal to, the belt moves at 75 feet per 1 minute. If you set that equal to 30 feet and you solve for a variable, it'll tell you how long it takes for the package to travel that 30 feet. So we did this last week. This is a proportion problem. It's a special right triangles problem and a proportion problem. If you crisscross multiply, your 75x equals 30. And if you divide by 75, then your x, or how long it's going to take the package, is going to be equal to 30 divided by 75, which is 0.4. 0.4 minutes. Alright, so the first part of that question, how far do the supplies travel? They travel 30 feet. Part B, to the nearest tenth of a minute, how long does it take the supplies to move to the second floor? Nearest tenth of a minute, so that's going to be 0.4 minutes. 0.4 minutes.